Dear students, today we will continue with the arrays once again. We have already seen the basics of arrays and some basic programs related to the usage of arrays. We will see few more programs related to the arrays. We can see some more logic creations, some more operations related to the elements present in an array. So first program we are going to discuss now is how to display only the prime numbers present in an array. Just display the prime numbers present in an array. Now just look at the logic. We will see the statements one by one. So first of all, we are having the main, then see the first statement, size n, a of 20 is the array, I is the counter variable. Now we are setting a flag variable for setting. If it is satisfying the condition, we are setting a flag variable just like 0 and 1. Based on the flag value, we can say like true or false. If the flag value is 1, that is true, or if the flag value is 0, accordingly we can have some decision. Just for making a decision based on the value of flag variable, we are using flag. Normally we are using flag variables for this particular purpose. Then we are having one more variable that is called as j, because in this case we require one loop, that is normal for loop. Inside that I require one more loop for one more iteration. We will see what is the requirement for that second iteration. For that second iteration I am using this j variable. We will see that. Okay, now enter the size of array. Just that's that same code, read n. So for example, I am reading n is equal to 3. N is equal to 3 I am reading. Then for I equal to 0, I less than n, enter the number and scan a of I. It will read all the values present in the 3 memory locations, a of 0, a of 1, a of 1 and a of 2. So a is the variable, array variable points to the base address. Then 0th location, assume that I am reading a value 3 for example. Then here I am reading the value 4. Then here I am reading the value 5. So what is a prime number? Prime number means a number which is having exactly 2 divisor. That means it is divisible by itself and divisible by 1. So if a number is divisible by only these two, that number can be called as a prime number. Okay, so first let us see these three numbers. 3 is divisible by 1, 3 is divisible by itself, 3 by 3, 3 by 1, but no other numbers, 3 by 2, it is not possible, right? So 3 is a prime number. Now let us see what is 4. 4 divisible by 1, it is divisible by 4 itself, but it is divisible by 2 also. So 4 is not coming under prime number. Okay, then 5, what about 5? 5 divided by 1, that is correct. 5 divided by 5, that is there. Now 5 divided by 2, wrong. 5 divided by 3, that is wrong. 5 divided by 4, that is also wrong. We are not having any division possible with other numbers in 5. So exactly with 1 and itself, this is also coming under the category of prime number. So similarly the other numbers like 7, 11, all these are examples of prime numbers. So our aim is to find out the prime numbers present in this particular array. So we need to check one by one. So first of all, reach the first location 0, check whether 3 is prime or not. Then come to first location, check whether 4 is prime or not. If correspondingly if it is prime, just print that. Similarly, come to the second location, check whether 5 is prime or not, print that. That's all. Just like in the previous example, we were checking each and every number is even or not. Similarly, here with each array element, we need to check whether this element is prime or not. So we need to apply prime logic for each of the elements present in the array. Okay, so let us see this example in detail. That means the loop will be described in detail. Okay, so let us see. So after reading we can see, the other operations. What are the other operations that is to be done for finding the prime numbers present in an array? Okay, so let us have a look. So this is the loop where we are applying the prime logic. This is the loop just after reading. So before that we are having only reading. Okay, so now for I equal to 0 to n minus 1, that is for traversing through 0, 1 and 2. So automatically first I value will be 0. Okay, assume that. Now next statement, just like in the previous example, you have set sum is equal to 0. We are setting the value of flag as 0. Okay, initially we are setting it as 0. Now we are in the 0th location. First iteration we are entered into the array. So 0 is less than 3, right? So we are entering into the array. Just set flag is equal to 0. Flag will be set as 0. Now we are moving into another loop. So what is the requirement of this loop? Just listen carefully. After reaching this first element, now for finding whether this 3 is prime or not, we require another loop. So already in the simple logic itself, for checking whether a particular number is prime number or not, we require a loop. So that loop we are applying here. So the outer loop is for reaching each individual element in the array, and this inner loop is for checking this individual element whether it is prime or not. Okay, now look at the feature that is available in this inner loop. Now we are having that second iterative variable j equal to 2. It is starting with 2. So you might be wondering why we are using this 2. Just listen carefully. J is equal to 2. Why it is not starting with 1? 1, every number is divisible by 1. So we are not considering 1. From 2 onwards we want to see whether that number is divisible. That is why we are starting this inner loop with 2. This is a different logic. We are having some other logics also available for finding the prime. It is a different one. Okay, similarly 3 or 4 logics are there for finding or checking a given number is prime or not. Okay, now j less than equal to, see, first value 2. Now j less than equal to a of I. Now a of I is 3. 3 divided by 2. 3 divided by 2. 3 divided by 2 means it will get 2 and remainder 1. So 3 just divided by 2 will get 2. 3 modulus 2 will get 1. So 3 divided by 2 will get 2. So here we will be getting 2. J less than. So j initial value is 2. J less than equal to 2. 2 less than equal to 2, that is true, right? It will enter into the loop. Now inside that it is having another operation. Now take this element a of I. If a of I, that is 3, if 3 modulus j, that is 2, 3 modulus 2. Now we are doing 3 modulus 2 we are taking, whether it is equal to 0. Whether it is equal to 0. Whether it is equal to 0. In this case it is not equal to 0 because we are getting 1 remainder. So it will not enter into this. it will not enter into this, because 3 modulus 2 is equal to 1. Okay, now what will happen? It will come, go for next iteration, j is equal to j plus plus, that is 3. 3 less than equal to ai by 2, a of 0 by 2, that is what? 2. That is wrong. 3 less than equal to 2, that is wrong. It will exit from the loop. It will exit from the loop. Which loop? Sorry. It will exit from this loop. It will exit from this loop. Okay. Now, if flag is equal to 0, is there any change with flag? Our initial value was 0, right? Now, also the value of flag is 0. If flag is equal to 0, printf a of I. Now, 3 will be printed. 3 is a prime number. Okay. Then it will go for next iteration with 4. I is equal to 1. It will come here. I is equal to 1. It will come here. I less than n. 1 less than 3. True. It will enter into the loop. Then again setting the flag. Once again it is setting as 0. Then for j equal to 2, again for the next number from 2 to the number divided by 2. That means half, up to half, whatever be the number in the array, up to the half of that, it will be checking with all the numbers. So 2 will be checked. 4 divided by 2. 4 divided by 2. That is again 2. Okay. So 2 less than equal to 2. True. It will enter into this inside the body of the loop. If a of I, that is 2, that is this 2, modulus, sorry, this 4 itself, modulus 2 is equal to 0, 0. It will check for that. 4 modulus 2, it is 0 because we are getting the exact division here. So we are not having any remainder. So we are getting a 0. What will happen? It will enter into this. Flag is equal to 1. Flag is equal to 1. It will break from this loop. It will break from this loop. No, that means it will go out of this loop. It will not go to this particular portion. Go for next iteration for getting the next value. I equal to 2. 2 less than 3. That is true. It will enter inside. Again set the flag as 0. Again set the flag as 0. Okay. Now again next value. What is our next value? Second location we are having the value 5. 5 divided by 2. We are getting 2. Okay. So what we can do with that? What we can do with that? What we can do with that? Here 5 divided by 2, the value that we are getting is 2. Okay, so 2 will be given here. So 2 less than equal to 2, it will go for checking, enter into the loop, check 5 modulus j. Now it will be very clear. 5 modulus j, remainder is 1. So it will not enter into this loop. It will go out here. Okay, it will go out of this loop. Next iteration also it will be exiting because j is equal to 3. It will be a failure. So it will go out. Then because we are not having no more value for comparison, I mean for division, okay, or for finding modulus, we are not having any other value. So it will come over here and it will check the current value of flag, that is equal to 0. Will produce, again it will print the value of a of I. Okay, so there is a correction here. here 3 divided by 2, it is actually 1. Okay, it is actually 1 to 1, and we are having a remainder here. So I have mentioned it wrongly. So listen, what was the situation there? J is equal to 2, j less than equal to ai by 2. So j is 2, j less than equal to ai by 2, that is 3 by 2, that is 1. 2 less than equal to 2, that is actually wrong. It will exit from that. It will exit from that for loop. There itself it will exit from that loop, and it will check flag is equal to 0. Okay, the flag will be 0, and it will print the value a of I. Okay, so just listen here. 3 divided by 2, it is not 2, it is 1, and we are having a remainder 1. Okay, so here itself the condition fails. It will go out of the inner loop. From this loop it will come out. There is no change. Automatically the flag value 0 will remain as 0 itself. Okay, so this is how we are finding the prime numbers present in an array. I hope it is clear. Now this logic is very much helpful to the situation where we are using more than one loops. That means a nested loop is included here, one for traversing through the array, and second one is for finding the logic. We are using another for loop. So this is a different logic used for finding a number is prime or not. We are having other logics also that is already available. Okay, so we can utilize that also in this particular inner loop. So that for loop will be slightly different. Okay, so this is the case where, so here in this example 3, 4, 5, the 3 and 5 will be printed as prime, and 4 will be considered as not a prime number. Just once again listen, this was wrong. 3 divided by 2 is actually giving 1. Okay, initially I have said like it is 2, it is wrong, it is actually 1. Okay, so in that case also it will exit from inner loop, and will have the value of flag is equal to 0, and it will print the number as a prime number. Okay, so that is all about finding the prime numbers or printing the prime numbers present in the array. Now we will see another program that is called as linear search. Linear search, searching for an element present in an array. Searching for an element present in an array. Suppose if you are having an array and I am searching for a particular number, whether that number is present in the array. Okay, so here once again we'll have a similar array, like we are having only 3 numbers. I am taking only simple arrays. The same thing will work out for any number of elements. So just for understanding the logic, I am using simple arrays. It will work for any number of values. So assume that we are having 3 values, 5, 6 and 7 in the array A, 0, 1 and 2 location. Okay, let us try to search for a particular element based on the logic given. This search algorithm is called as search, that is linear search. Linear search means we are searching first element is being compared with the key element, that is the element that is to be found. Then similarly go to the next location, check whether that number is equivalent to the number to be found. Similarly go to the next one, check whether that number is equivalent to the given number. Okay, similar. So that is why linearly from one point to another point we are trying for a search. So here in the declaration we can see there is the size of array A of 20, then I is for the for loop, then we are having an index. We are having an index variable for setting if the element is found or not. Just for setting a value we are using an index variable. Just like the flag variable we were using in the prime program, previous program, we are following index. We will see what values we are assigning in this index. Now enter the size of array, read the size. Now we are reading the size, n is equal to 3. Now this is the reading for loop for I equal to 0 to n minus 1, I less than n. Enter the number a of I. A of 0 will be added here, a of 1 will be added here, a of 2 will be added here, then it will exit from the loop. Okay, now let us see the remaining portion. Now let us see the remaining portion of the same program, the logic where we are actually applying for checking for a particular element. Let us see once again. So you can see, first of all we need to enter the element that is to be searched. Okay, so from this array I want to search for a particular element, right? So enter the element to search, just like reading the enter the size of array, scan of ampersand key. So I am using one more variable, key. So that was already there, I think. Key that is to be declared here. So that was not given there, so that is to be declared. Okay, so key variable to be declared, that is the element to be searched. Now enter the element to search, read that into key variable. Now look at this one, index equal to minus 1, index equal to minus 1. Why we are setting index equal to minus 1? This is the initial value given for a variable index. So the real purpose of this index, whether the element is found or not. If it is found, it is in which index location. So that is the actual purpose of using index variable. It is found in a particular location, in a particular index like 0 or 1 or 2. We need to find out the exact index where that element is being found. So based on this index value only, we are deciding where it is found. Okay, now let us see the next loop, the real usage of this index, and why we are giving a minus 1 value. We will see that later. Why we are not giving 0. Later, previous case we were using flag is equal to 0, right? But now here we are not using 0. Index is given as minus 1. Why don't we use 0? Or why we are using minus 1? We will see that soon. Okay, now this is the loop. So what is our aim? Iterate through these indexes starting from 0 to 2. Of course that is the exact working. Okay, starting from 0 to 2, check for each element. Each element must be compared with the given key element. That's all. Okay, so for I equal to 0, I less than n, I plus plus. So initially I 0, so this number will be selected. Now inside the loop, so I equal to 0, I less than n, that is true, it will enter into the array, enter into the loop. If a of I, that is a of 0, that is 5, if 5 is equal to key, double equal to key is a comparison, double equal to key is equal to key. Assume that our key, I am entering the key, I am entering a key as 7. I am entering the key as 7, that is the element to be searched. So 0th element, a of 0, will be compared with key. Whether it is correct or not, it is not correct, right? So it will not enter here, it will not enter here, it will not enter here, right? So you will see this when we are having a match. So what will happen? It will go for next iteration. It will go for next iteration. For I equal to 1, for I equal to 1, 1 less than 3, that is true. If a of 1 is equal to key, a of 1 is 6, 6 equal to 7, it is wrong. It will not enter into this loop. Exit from this comparison, these statements. It will continue with the next iteration. Then for I equal to 2, 2 less than 3, that is also true. it will enter into the body of loop if a of I, that is a of 2, that is 7, equal to key 7, that is true. Now it will enter here, it will enter here. Now it becomes true. Index equal to I. What we are assigning here, whatever be the value of I here, whatever be the value of I here, that I will be assigned to the index variable. So initial value was -1. Now that will be replaced with the I value, I. So now what is the value of I? 2. 2 is assigned to index. Then give a break. Break means it will come out of the loop. Now automatically will come out because we are not having further elements here. Now again, if you are having some more elements here, after finding this, it will come out of the loop. So that is why it is given as break. In this case, it was the last element, so automatically next iteration will come out. But if you are having more elements, we need to have a break. So after setting this I into the index variable, so 2 is assigned to index, then it will break out of the loop. Okay. Now if index equal to -1, that means if there was no change after iterating through all these 0, 1, 2 and up to n-1, no match was found, that means the value of index will still -1. Okay, now this -1 will be treated as the element was not found. Okay, now what about this one? So whatever be the iteration, whatever be the solution, whatever happens with this loop, it will come out of that. It will first check whether it is -1. Index is equal to -1. No, it is not, right? It is 2. So it will not execute this one. Else, the other case, if you are having some other value for index, if you are having some other value for index, it will print the search element found at index location, the search element found at index location, correction, the search element found at the index location, index, that is at the location 2. Now 2 is assigned here, the element found at index 2. Clear? So whenever we found that value for the first time itself, if you are finding that value, it will assign that index, then it will break from the loop. Then depending on the index value, if it is having the same initial value of -1, no elements found. Now if it is having a different value than that, the element found at index location, that I value to be printed here. That means that is assigned to index, that is to be printed here. Now you might be knowing why we are having this -1. Why this -1? Because assume that if we are traversing through, now assume that if this 7 was present in the first location, what will happen? First iteration, a of 5, a of 0 is equal to key 7 is equal to 7, it will be true. Index will be assigned as 0 here, because array is having a 0th index also. So that is why here we cannot assign 0. Okay, listen carefully, we are having a 0th index location also. So that is why we are going for a negative. We are not having any array location, so we can have any other value, even -1, -10 or any negative value can be included here. That is the reason why normally we are using 0, but here 0th index may also find the value. In that index also we may find the value. So as it is not or it is part of this array, we cannot include this as the initial value of index. So here also we are having the possibility of 0. So there will be a confusion between these two. Here 0, again 0 will be assigned, so there will be confusion. So here give -1. -1 is the negative case because the element not found. 0 means it is a positive symptom that the element is there. It is found inside the array in the 0th index location. Okay, so this is a simple logic for finding an element present in an array. This search algorithm is called as linear search algorithm. Linearly we are searching for a particular key element, and we are comparing according to the comparison and according to the index location. We are not only finding the match, we are also finding the location where that element is actually present. That will also be printed. Then this is the main end. Okay, so this is the logic for linear search. This is one of the major algorithm used with searching. There are various categories of searching algorithms available, but this is the basic searching algorithm, linear search, and we can have different logics like other types of searching like binary searching, etc., etc. We are having several other mechanisms also available. So that is all about searching algorithm and searching program related to arrays. So today we were discussing about some more programs related to arrays, like checking for the elements, the prime numbers in the array. Similarly, checking for prime numbers. Okay, we are looking at only two programs. One is for finding prime numbers, and second one is for searching for a particular element present in an array by using linear search. And next session we will see one more major algorithm related to the array concept. Thank you.